Yeah, please, we can hear you.
Sorry. So I said we are integrating sum, which is addition, and difference, which is subtraction. Do you get it? So the first example that we are working on is the integral of 3x squared plus 5x dx. And we know that when you are differentiating a term, it has a rule that needs to be followed. And the rule says that if the term has no coefficient, we divide it by the power. We divide by the power. How do we divide by the power? We add 1 to the existing power. So over here, the existing power is the n, and this is the one that we are adding to. Then we divide the entire power by the what? Coefficient, or we divide it by the term. If it has a coefficient, then we say that let the coefficient be represented by a, and the power, we divide the power by the coefficient, then add our constant, which is k. So looking at this example that we have here, fortunate enough, we have what? Two terms. We have two terms, and each term has a power, or each term has a power, and each term has a coefficient. So we are going to use this rule because it is having a coefficient. And we say that with this rule, when we add 1 to the exponent 2, we are going to get 3, and we are dividing the 3 by the coefficient. Here we have power 1. If you add 1 to power 1, it will become 2. So we divide 2 by the coefficient. Then we add a constant term, which is k. So 3 can go into itself. You get x cube or x power 3, x cube or x power 3 plus 5 over 2 x squared, 5 over 2 x squared plus k. That's the first That's the first solution or the first answer to the first question. Let's move on to the second one. You are done with this. The second one says for integral 4x squared plus 2x dx. So the same approach, integral 4x squared, integral bracket 4x squared, integral 4x squared plus 2x plus 2x dx. Right. So we are going to get we are going to get 4 over 3 times x power 3 times x power 3 whole plus 2 plus 2 over 2. Why 2? Because the power here is 1. When we add 1 to it, it becomes 2 times x power 2 as our constant k. Don't forget the constant. If you forget the constant, all the work that you've done it in vain. So you are going to get 4 over 3 x cubed plus 2 go into itself, so plus x squared k plus x squared plus what? K. Always take note that k is always what? Positive. Take note that k is what? Always positive. So this is the solution, the second question. I hope each and everyone can hear me now. So this is the solution to the
Yes,
second
sir.
question. All right, thank you. So the third one is integral of 5x squared plus 2x dx. Integral of 5x squared plus 2x dx. Integral of 5x squared dx. Good. So solution, we get 5 over, if you add 1 to the 2, you are getting 3 over 3 times x exponent 3 plus 2 over 2 times x squared times x squared plus k. That's our constant. I'm saying it again. Don't forget the k. If you forget the k, all the work that you've done, you've worked in what? You've worked in vain. Over 3 x cubed plus x cubed plus k. This becomes our final answer. Note that don't leave your answer in decimals. Don't try and break this one down. Leave it in the fraction form. Leave it in the fraction form. All right, let's proceed to the next question. The next question is this. For this one that we are going to do, you see the sign has changed. We have the sign to be negative here. We have the sign to be, yes, Mr. Patrick, please, you can talk.
This is the question we just solved right now. You check it very well because they say 5x squared plus 2x, but the exponent of the 2x, you make it 3, which is supposed to be x squared, not x cubed.
Okay, thank you for your question. So we say
The
that
exponent.
when we are integrating, we add 1
Yeah,
to the exponent, right?
I understand that because you see the question says 5x squared plus 2x. That means the exponent is 1. So if you
Yes,
say 1 plus 1, it's supposed to be, it will be 2x squared, right? All over 2.
yes.
Uh, but you see the
Okay,
final answer the
I've
final
seen
answer
it.
is,
I've seen it. Thank you. Thank you.
okay.
Thank you
Okay.
very much. Thank you, Mr. Patrick.
Okay. Okay.
So let's move on to the next question. The next question says x squared minus 3x dx. X squared minus 3x dx. X squared integral of x cubed minus 3x. So over here we are now working with difference x. Alright. When you are integrating, you are going to get the same thing. Let's say this one, you are not going to, this one, it has 1 coefficient. One term has a coefficient, the other term do not have what? Coefficient. So let's take note. So we say we have 1 over 4 x power 4 minus, this one has a coefficient, so 3 over 2, because here is 1 and we've added 1, so making it 2 x squared plus k. So that becomes our final answer, because over here we cannot do anything again. We leave it like that. We leave it like that. The next question. 6x squared minus 8x dx. 6x squared minus 8x dx. So IV integral 6x squared minus 8x dx. All right. So the 6x, we have, so the 6x, we have 6 is the coefficient over 3, which is the power, times x exponent 3 minus 8, which is the coefficient, over 2, which is the power, times x squared plus k, which is the constant. Once again, let's bring our constant. So you know that 3 can go into 6 two times, so we have 2x cubed minus, then 2 can go into 8 4 times, 4x squared plus k. That becomes our final answer. But please, let's take note of the operational signs when you are dealing with it, because at some point in time you will be given all the two. You can get a term, or let's say you can get a function to integrate where you have both addition and subtraction. So when you are integrating that thing, please take note of how you go by such functions, because sometimes you might interchange the functions. So let's take note. So let's come to the trials, and that will be the last thing to do for the day. And hopefully, I'm praying that tomorrow we get time and meet to complete the entire topic. So the trials, we have 4 questions. Oh, sorry, one didn't come. Probably it was 5, but one didn't come. So let's manage the 4 like that. So we have 3x. So it says integrate the following functions with respect to x. We have 3x exponent 5, 3 bracket x plus 1 exponent 5, 4x cubed minus 5x plus 6. Then we also have bracket x cubed plus 1 all exponent 2. So let's take the first one. Let's take the first one. So if you are taking the first one, trials. Trials. Please, we've seen the question. So we can solve and start typing the answer in the message or the chat box. 3x exponent 5 3x exponent 5. So you see, let y equals to the integral of 3x exponent 5 dx. Alright, so we are going to get 3/6 x exponent 6 plus k. As easy as that. As easy as that. As easy as that. As easy. So we are going to get 1/2 x exponent 6 plus k. As easy as that. Please, who had that answer? Who tried to solve it and had that answer? Right, so let's move on to the next.
I did.
Okay, thank you. Thank you. Thank you very much. Next one that we have is I. We have 3 bracket x plus 1 bracket close exponent 5. So you see if there is no integral sign like this, we say let y. Explain it a little bit. Let y equals to the integral of 3 bracket x plus 1 of exponent 5 dx. You get it? Explain it a bit so that your workings or your solutions becomes what? Easier. So let's take note of that. So over here, we say let u, because this term is a composite term. We say let u equals to x plus 1. X plus 1. So we differentiate this. With this one, we are going to differentiate it. So we say du d1, du dx, sorry, du dx over here is equal to 1. So back from differentiation, we know this. Then please mute yourself. Du dx, du is equal to what? X. Du is equal to dx. The reason why du is equal to dx is because when you multiply this by 1, you are going to get what? Dx. So take note. So you see integral 3u exponent 5 dx will give us 3 integral u exponent 5 dx. So now that we are about to use our normal rule that we use for the differentiation. When we are differentiating this, we are going to get 3 bracket 1 over 6, because when you add 1 to the 5, you're going to get 6. 6 u exponent 6 bracket close plus k. You get it? But 3 times 1 is what? 3. So you're going to get 3 over 6 u exponent 6 plus k. So the final answer, you're going to get 1 over 2 u exponent 6 plus k. So the final answer is 1 over 2. We bring the what, or we substitute what u is. We say that let u equals to what? X plus 1. To bracket x plus 1 exponent 6 plus k. Any question here? Any question here, please? The reason
Hello,
why
sir.
we, any
Hello, sir.
question? Yes.
Yeah, please, can you go over this?
Okay.
This particular for me.
Okay. So look at this. I know that it might be a little bit confusing, but when you look at this term is a composite function. I think back in our previous lectures, yes, I think, yes, back in our previous lectures, we learned about what composite functions are. And you said that in order for you to differentiate, that was during the differentiation class. In order for you to differentiate a composite function, you need to do what? Separate the two terms. But this one, if we are to do what? Integrate it, we can go straight and integrate it. But if you go straight, that's not the correct way. So in order for you to differentiate it, you need to let u represent the term in the bracket. Then you differentiate it. After differentiating it, then you bring it back. You bring it back. Or yes, you bring it back. You bring it back. Then you let u, as you said earlier, that u should be equal to x plus 1. So you are now letting u represent the entire term that was in the bracket. Then you, from there, you differentiate it as we were using what? The normal rule of what? Integrating. You get it? So in order to integrate it, you send it back to our normal term, then you use the normal rule, which is 1. Yes, Mr. Kenneth, please, you can talk.
Yeah, so, so please, how do we identify that the question is an integral question when they don't indicate anything like that?
Okay, that's a good question. So let me see here. So the question itself will tell you. So look at this. The heading says what? Integrate the following functions with respect to what? S. So what are we doing here? We are what? Integrating the term. So if it is differentiation, they will tell you differentiate the following functions with respect to what? You understood now?
Yes, sir.
Thank you. So with this particular question, we have what? Two alternatives. One alternative is this way, and the other alternative is go straight. But that one, you will do what? To bring the three. So let's say we are using the other alternative. The other alternative, we have this. So we bring the three here, then bring our integral sign. Then we have our x plus 1 exponent 5 dx, right? Then this rule says what? Three bracket 1 over, what are we having here? 5 plus 1, 6. 6. Then we have the entire term here, x plus 1 all over what? 6 plus k. Plus k. Alright. So we are going to get 3 over 6 bracket x plus 1 exponent 6 plus k. You get it? It's the same as this. The reason why you have to go for this approach is because of what the component, if it's a composite function, you need to differentiate the x. Like we want to differentiate the x. That's that. You get it? We want to do what? Differentiate the term x. That's the reason why what? We prefer, or most lecturers prefer what? This approach than this. If you do like this, you are not wrong. But most lecturers, they do what? They prefer the first alternative that we use. So let's take note of that. All right. Please, is your question answered? Please, is your question answered? All right. So now let's move on to the next question. The next question says 4x. The next question says 4x cubed minus 5x plus 6. 4x squared minus 5x plus 6. All right. So when you are integrating this term, you say let y equals to the integral of, you can choose to put it in a bracket, x cubed minus 5x plus 6, bracket close, x. All right. So over here, you see, over here, you see 4 over 4 x, 4 over 4 x, x exponent 4 minus 5 over 2 over 2 x squared over 2x squared plus 6x plus 6x over 1. Let's bring it, plus the constant what? K. So the reason why when you see a constant, we attach it with what? X. When you are what? Integrating. When you see a constant, we add what? X to it. You get it? Because it is addition. Because it is what? Addition. That's why integration will bring what? X to what? A constant. Do you get it? Or a number without what? Any X. Do you get it? But if it was to be differentiation, we subtract. So in differentiation, here could have been what? 0. But in differentiation, we add X to it. So let's take note. We are going to get X exponent 4 here, because 4 will go into 4, 1. Then 5 over 2 x squared plus 6x plus k. That's our final answer. Any question? Any question? Any question, please? So if there is no question,
Hello,
then
sir.
yes, please.
Hello,
Yes, please can
sir.
talk.
With the 6s, after you introduce the x, won't it be like 6s square over 2?
No, you see, over here, there is no x here, right? Are you looking at where I'm
Yeah,
pointing?
yeah.
There is no x here. So if we add the x, we are adding only 1. Do you get
Okay.
it? The x that we are adding comes with the power 1.
Oh, okay.
Yes. So suppose
So,
that
so okay.
um,
So for if the x were to be there already, it
yes,
could be
it
two
will
x.
2x,
Okay,
x squared. Do you get it?
sure,
It is
sure.
addition. It is what? Addition. So let's take note of that. Thank you for your question. Thank you for your question. Any other question? As we bring our class to an end, any other question? If not, then thank you for your time. You've done very well. Thank you very much. Thank you for